All right, we're ready for week 5, video number 1. I hope that you made it successfully through week 4 and made it through that first test. If you have not yet done so, I would highly suggest printing off this study sheet that I linked in the announcements last week. And so look at the week 4 announcements if you have not yet printed out. These are the ones that you're going to be focusing on this week. Is these basic trig derivatives. And this is just a study sheet, which means you'll need to use it to study, but you will need to have these memorized so that you can successfully do what we're doing right now. And then it's also nice because the unit circle is here. And so if you need to use that for reference, like while you're doing your homework, that's okay. But again, you need to be able to kind of sketch that out and figure that out, even if you can't look at the unit circle during an exam. Okay, so I picked only 6 problems for us to go through the 4 types of problems. So a lot of it is just more derivative rules, but throwing in these trig functions. But luckily, a lot of it works the same. And so the power rule still works the same. Product rule still works the same. Quotient rule still looks the same. So the first 3 that I picked kind of go through all of those. So I've got just a basic one, and then I've got a product rule one and a quotient rule one. So I'm just going to kind of show you that it all works the same. So this first one, actually, please don't be tricked. This looks like just one thing, and you might think, oh, that's just like one piece. But this is product rule. This is a function times a function. And if you don't find your answer using the product rule, it's not going to come out right. And remember that the product rule is always set up like this every single time. So if you just fill in those spots doing the product rule, then it'll be just fine. Okay, but it is a function times a function. So the product rule is always the derivative of the first times the second the way it is, and then the first the way it is times the derivative of the second. And because it's commutative, if you kind of mix those up or switch these, it all comes out about the same. But I'm going to go in the order that I say it, just because that makes it easier to remember the quotient rule. So derivative of the first is the derivative of this, just this piece, which is going to use the power rule that we learned last week. So we're going to bring that 4 down front. So that's going to be negative 24/5 x, and then you reduce that by 1, so cubed. And then times the second one just the way it is. And then you can put parentheses around the x. Newton will kind of take it either way, and so that's up to you. But make sure you either multiply here or use parentheses. I usually do parentheses when I'm typing it into Newton, so I'll make it look just like that. And then plus, and then you do the first one just the way it is, left alone, just bring that straight over there. Okay, so the derivative of the first times the second the way it is, plus the first the way it is times the derivative of the second. And then that's where this little sheet will come in handy until you get these memorized. So that's cosine x. So you look on here, and the derivative of cosine x is negative sine x. And so until you get those memorized, it's kind of nice just to look at there. Okay, and then again, just like I've been saying, and I'll kind of stop saying this so that you don't keep hearing it forever, but you can multiply this together. A negative times a negative is a positive. So you can make it look a little prettier if you want, but that's a good answer, just the way it is. So I'd probably just leave it alone. Okay, and then this one's easier, number 2, because it has a plus sign in the middle. So there's no product rule here, there's no quotient rule here. You're just finding the derivative of this piece, derivative of this piece, done. Okay, and so if I want to find the derivative here, I just take the derivative of each one. So 1/3 x, the derivative is just 1/3. And then this would be 3. And then again, you go to your little sheet, and cosine, remember, was negative sine. And so cosine is still negative sine x. And again, if you want to make that look a little better, you could do 1/3 minus 3 sine x. And you can put parentheses around the x, but because it's just an x, it's going to count it both ways. And so that's up to you. So that one's I love, because it's just a polynomial kind of thing, like different pieces. And so it's easier. So if you see something like that, it goes really fast. Okay, and then the third one I picked uses the quotient rule. And we learned that last week, and that's set up a lot the same as the product rule, but with a minus. And then it also has that denominator. Okay, and so I would just kind of get that all set up. And then that negative sign has to find a home. And so it doesn't really matter where you put it. I'm just gonna go ahead and put it up here actually. Just give it a home, okay? So don't leave it out front, either put it with the numerator or the denominator. It's gonna be fine either way. I just chose to put it up there. Okay, so here we go. So the quotient rule says take the derivative of the top. Well, remember cosine is negative sine, and then there's a negative here. So if this is negative sine times -2, that's gonna be +2 sine x. The derivative of cosine is negative sine. So that's where that comes. Times the denominator, just the way it is, minus the numerator, just the way it is, times the derivative of the denominator, bring that 4 down, would be 28x cubed, and then over the denominator squared. And you're welcome to kind of multiply. This wouldn't be too bad. That would just be 14x to the 4th sine x. Negative times a negative is a plus. 2 times 28 is 56x cubed cosine x all over 49x to the 8th if you square that. So I mean, that one wouldn't be bad to simplify, but you don't really have to, so whatever you want. Okay, then there's this little game that we get to play with higher order derivatives. And I don't know how much you remember from probably in an Algebra 2 class when you first learned complex numbers and you learned that like I to the 4th will take you back to +1, and then I to the 5th would be the same as I, and I to the 6th would be the same as I squared. This is basically the same thing. So this says find the 14th derivative. So that means you have to find the derivative 14 times to figure out what it equals. And the point of this is try to help you see shortcuts, because I want you to look on here at sine and cosine. The derivative of sine is cosine, and then cosine's negative sine. And then it would go back to, again and back and forth. And you'd end up popping back and forth between cosine and sine, but changing the sign on it. So they're trying to kind of get you to see shortcuts here. And so the easiest way for me to explain this is just to find the first 4 derivatives and then just kind of explain how it works. And hopefully you just kind of get faster. But I'm going to go kind of step by step here because I want you to visually see what's going on. Okay, and so using the little study sheet, and plus we've already done it 3 times before, we know that the derivative of cosine is negative sine. So when I find this first derivative, I'm going to change the sign. So it's going to go to +2, and then it's going to go to sine x. Okay, and then the derivative of sine is just cosine, so it stays literally exactly the same. Sine, like the positive and negative part, like all of it, like it just stays the same. Oh, but it goes to cosine. Sorry, that's very messy. Just pretend like that says cosine. Okay, so sine goes to cosine, but we don't change this, right? And then the cosine is negative sine again, and so now we're going to bounce back to a negative, but we're going to switch back to sine. And then the derivative of sine is just cosine, so it stays the same here, but we just switch it back. And then this is the part I want you to notice. I want you to notice that this brings us back around to where we started again. And so this we could technically call 0, like our starting point. And so the 4th derivative takes us back to where we started, and then we would loop back around. So if we're trying to find the 14th derivative, follow with me here. Ready? 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14. And so that would be the one that we would pick. And what you kind of start to see is that every 4, you're going to loop back around. And so if you look at the number 14, I can take 12 of those out because 12 is a multiple of 4. So the 14th derivative is going to be the exact same thing as the 2nd derivative. So really, if I had just found the 2nd derivative, I could stop. So using that logic, understanding that every 4 loops back around to where you started, hopefully you can see the joy in finding the 36th derivative. Because 36 is a multiple of 4. So by the time I loop around to find the 36th derivative, I'm going to end up exactly where I started. So I actually don't have to find anything on this one. Because this is asking for the 36th derivative, it's going to be exactly what I started with. Done. So my starting point is my 36th derivative, right? But if it had asked for 37th, then I would have to find basically the first derivative, right? And then that would give it to me. And so just look at this number and just remember that every 4, you kind of loop back around to where you started. So you can always take out multiples of 4. So that should help you do those pretty quickly, okay? But that number right there is just telling you how many derivatives you're doing. All right, and then we go back to where we ended with week 4. So the lessons at the end of week 4 were finding the equation of a tangent line. And now we're going to start week 5 with finding the equation of a tangent line. So I'm going to kind of go over this the exact same way that I did last week. So to find the equation of a tangent line, we need a slope and we need a point. Okay, and we're going to do this the same way we did last week. Yeah, they're going to throw in trig and it's going to look a little weird and it might not be your favorite thing and whatever, but it's okay and we can still figure it out. And so that's what we're going to do. So to find the slope, I have to first find the derivative, right? And this is luckily no product or quotient rule. We can just go right through because each of these are separate terms. And so the derivative of -3 cosine x, this one's just going to keep coming up. Cosine is negative sine. So negative sine is going to turn that negative into a positive 3 sine x. And then here's the beauty. That's just a number, so the derivative is 0. That's just a number, so the derivative is 0. That's just a number, so the derivative is 0. Notice there's no variables in there. Pi is a number. So number, 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 constant, 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 0, 0, 0. So those are just gone and that's it. And then we just got to plug this in. And so we're going to find the derivative at 3 sine pi over 4. And you'll remember that at pi over 4, both of the coordinates are √2 over 2. And so that's simply going to be 3 √2 over 2. Okay, so we found the slope. Check, done. Now we've got to come over here and find the point. And to find the point, we plug this into here. And so we're going to do f of x equals, or you could do y equals, and then -3 cosine pi over 4, because we're going to plug that in. Let's see if I can squish all this in here. -2 plus 3 √2 pi over 8 plus 3 √2 over 2. Okay, so the only part I have to figure out is this piece right here. And again, pi over 4 is just √2 over 2. And so that piece would turn into -3 √2 over 2, but there's already 3 √2 over 2. And then notice this is going to be beautiful, right? And then -2 plus 3 √2 pi over 8 plus 3 √2 over 2. Okay, so that's looking quite nice right there. All right, so I have a slope and I have my point. Here's my x value, and this whole entire thing is my y value. So if I wanted to write it as a point, I'd have to do this and then put pi over 4 right here to write it as a point. So that's your x and your y. Okay, that whole thing is your y. Seems a little crazy, except these cancel. So really you could just kind of eliminate those. And so really this is your y. Okay, and we're gonna do just like we did last week. And we're gonna do y minus y1 equals m times x minus x1. And that's gonna be y and then minus, these cancel, so I'm gonna just ignore those. So I'm gonna subtract those, which is gonna change the sign. So it's gonna make it +2 and then minus 3 √2 pi over 8 equals m, which I found right there, 3 √2 over 2 times x minus pi over 4. And then there's two kinds of problems here. Sometimes it asks you to, on a little picture of a graph, drag the point to the intercept. And sometimes it asks you to actually type in the equation of the line, but the work is all the same. So I don't care. Please don't guess though. On the ones that have you drag the point on the graph, please don't guess, because it's sometimes pretty difficult to guess exactly right. And so it's way better to do this. So then I'm going to add these over, distribute that in, So y equals, if I distribute that in, that would be 3 root 2 over 2 x. And then I'm going to subtract that 2 over minus 2. And then this is the part I want you to notice. When I distribute this, that's going to be minus 3 root 2 pi over 8. And that's the same as this. And so this is actually going to cancel with that. And so this is going to be my final answer. So if it's the kind where you type in the equation, you type in that and you're good. If it's the kind where they give you the graph and they give you like all of these different lines, like sometimes it's a bunch of little curves or whatever, and they'll have a point like already on it, and they'll be like, drag the dot. Always drag the intercept dot to match this. So this would have an intercept at -2. So I'd come down here to -2 and I'd plant the dot. And then that would make that tangent line up just perfectly. So please don't guess on the graph ones. Do this and then just drag that dot to match your intercept. Okay, no guessing. Guessing is going to lead you to getting wrong answers. And then it's going to spiral you back and make you do a lot more work than it would have been just to do it right the first time. So anytime it's any kind of an equation of a tangent line, just make sure you follow the same steps. Find the slope, find the point, plug it into your point slope form, and then do either type in the equation or find the intercept right there. Okay, but you're not going to know the intercept without doing the whole equation. So that is the first homework assignment from week number 5. I hope that I picked all the types of problems, but as always, we have the recitation meetings. And so if you're doing the homework and you find one that I didn't cover or it's giving you problems, then just write that problem down or take a picture of it and then bring it to meetings so that you can get help. Hey guys, we'll see you and good luck on this one. I hope that helps.